Hi, in this video I will show you how to use engineering statics in order to find the force exerted on a bolt and all the joints in a bolt cutter. So for that reason I got an 18-inch bolt cutter and placed a 1/4-inch bolt on it, and at this position I drew the picture on a board. Now I want to find out the force exerted on a bolt and all the points when we apply 125 pounds of force into the handle. This point on the bolt cutter, I called it point A, B, C, D, and E. Now, a static by definition means a system that is at rest with no velocity and no acceleration. So in order for us to find the force exerted on the bolt and all the joints, let us start with this portion of the bolt cutter. This point is our point B, and this point here is our point A on that member, and this is our bolt, our 1/4-inch bolt on the blade. So at this point we are going to have a force exerted on that bolt. So let's call that force F bolt, and at point A we are going to have a force on that member AE. So let's call that force FAE, and the forces on point B will be force on point B in X direction and force on point B in Y direction. In order for us to have a static equilibrium, the summation of all the forces in X direction must be equal to 0, summation of forces in Y direction must be equal to 0, and summation of moment with respect to any point in our system must be equal to 0. So these are the conditions for static equilibrium. Summation of forces on X direction must be 0, summation of forces in Y direction must be 0, and summation of moment with respect to any point must be 0. So if the summation of all the forces in X direction must be 0, the only force we have in X direction is force on point B in X direction, so that force must be equal to 0. So force on point B at X direction must be equal to 0. So that means that at this point, point B, at that point of our bolt cutter, we only have a vertical force in Y direction. So force on X direction will be equal to 0 at that point. Now, in order for us to find the force in Y direction at that point, let's look at the handle. Let's say this is again point B, and this is our handle that we are applying 125 pounds force, and let's say this is our point C. So this is our handle point B, C, and a handle. So on point B, we have a force in BY direction which we want to find. And we know that the force on X direction on a B is equal to 0. Now if we take the moment with respect to point C, we know that the summation of the moment with respect to point C must be equal to 0. Moment by definition is equal to force multiplied by distance to the point that we are taking the moment. So that means let's assume that this direction is positive. So now we have force FBY, which is in a positive direction. We have force BY multiplied by the distance between point B and point C, multiplied by that distance, which is 5/8 of inch between that point and that point, multiplied by 5/8 of inch, which is 0.625, minus this force is going the clockwise direction, minus 125 pounds, multiplied by the distance between this force and point C, which this distance is 12 inches minus 5/8 inches. So it will be 12 minus 0.625 inch equal to 0. So we can now find the force at point B in Y direction by solving this equation. So force at point B in Y direction is equal to 125 pounds multiplied by 12 minus 0.625 multiplied by 11.38 inches divided by 0.625 inch. So that would be equal to 11.38 multiplied by 125 divided by 0.625. So that would be equal to 2276 pounds. So the force at point B in Y direction is equal to 2276 pounds. Or this is the same one, 2276 pounds. Now in here, at this point, if we are going to have a, let's say, force at point C in X direction, and let's say this is our force at point C in Y direction, now if we know that the summation of forces in x direction must be equal to 0. So we know FBX is equal to 0, so FCX will be also 0. And we know the summation of forces in y direction must be equal to 0. So the forces in y direction that we have is 125 pounds plus 2276 pounds minus force at point C in y direction must be equal to 0. So the force at point C in y direction will be equal to 2276 plus 125. Is equal to 2401 pounds. So this force will be 2401 pounds. Now that we have this force, let's go back to this picture and we take the summation of moment with respect to point A. So we know that the summation of moment with respect to any point must be equal to 0 in order for us to have a static equilibrium. So if we take the summation of moment with respect to point A, and let's again assume that this direction is positive. So we are going to have this force going this direction toward point A, which is the positive direction. We're going to have 2276 FBR multiplied by the distance between B and A, which the distance between B and A is 3 inches, multiplied by 3 inches minus F bolt is going this direction toward point A, minus F bolt multiplied by the distance between this point and point A, which is between the bolt and point A. That distance is 1 inch, multiplied by 1 inch equal to 0. So here we can find the force exerted on a bolt in an 18-inch bolt cutter will be equal to 2276 multiplied by 3 inch divided by 1 inch. So we're going to have 2276 multiplied by 3. So it's going to be 6,828 pounds. So the force exerted on a 1/4 inch bolt in an 18-inch bolt cutter will be equal to 6,828 pounds when we apply 125 pounds of force into the handles. Now let's see, we have all the forces except FAE, except the force on member AE. So now in this picture again, summation of all the forces in y direction must be equal to 0. So this is going up. Let's say this is positive. So 2276 plus 6828 6828 minus FAE equal to 0. So if we solve that, if we solve this equation for force in member AE, so force in member AE will be equal to 6828 plus 2276, which is 9,104 pounds. So this force is 9,104 pounds. So now this, we have found all the forces in all the joints, and joint D will be exactly like here. So the forces exerting on point B will be exact same forces that are on point B. So this is also equal to force in point D in X direction, and this is also equal to the force in point D in Y direction. So now we have all the forces exerting on the bolt and all the joints in an 18-inch bolt cutter when we place a 1/4-inch bolt on that bolt cutter and apply 125 pounds of pressure, of force into the handles. So I hope you liked it, and for the next video I am going to use a 24-inch a pipe wrench, a 24-inch pipe wrench, and I am going to place a 1 1/4 inch pipe into that pipe wrench and find out the forces that would be applied to that pipe when we apply again 125 pound force into the handle of this pipe wrench. So this will be our next example. If you follow my videos in very short period of time, you will be able to use engineering statics, especially in tool design and machine design, and the examples that I use will be the actual application of engineering static in real life. So next one will be the pipe wrench. Follow my videos. Thanks.